Are you wondering what software engineers actually do? In this video, I'll break down the job, how it works, and what a typical day looks like so you can decide if it's the right career for you or not. And I went from zero to Microsoft software engineer within 12 months. And now I help others fast track into software engineering too. So let's break down the term software engineer. As a software engineer, your job is to engineer software or to develop software. In the industry, software engineer and software developer are used interchangeably, but the core of your job is simple: to create software. So that begs the question, what is software? Well, before I go into what software is, let's talk about hardware. Hardware is the physical components that make up a computer. And so a computer could be anything like your mobile phone, your desktop computer, your laptop, your refrigerator, and other electronic devices. And so computers can only execute instructions if the computer can understand it. And the only thing computers can actually understand is binary code. Binary code is just ones and zeros. The one corresponds to an on signal and the zero corresponds to an off signal. So in the hardware, there's something called transistors, and if the electrical signal is on, then it's on, it's a 1. If the electrical signal is off, then it's off and it's 0. Now, trying to communicate with computers using this binary code is not practical, so humans have developed programming languages, which makes it easier for humans to give the instructions we want the computer to execute, because that software that we use eventually compiles down into machine code that the computer can execute. So for example, software can be a lot of different things. It can be like your refrigerator. When you leave it open for too long, it starts beeping. It can be your MacBook's operating system that runs your whole computer. Or it can be the browser that you're using to watch this video, or the code that powers YouTube that's allowing you to watch this video on YouTube. So software is how we program computers to do stuff. So originally, computers could only be programmed using binary code. And after binary code, we developed something called assembly language, which abstracts away the zeros and ones. So humans don't have to think about the binary code, and we can just write code in assembly language, and then that would compile down into zeros and ones. And then after assembly language, we've developed even higher level languages like C, which compiles down to assembly, eventually to machine code, which is binary code that machines can actually understand. And so this layer of abstraction has been building up over time. So today we have even more higher level modern languages like JavaScript or Python and other libraries and frameworks that does a lot of the work under the hood for us. And so these levels of abstractions have allowed us to build more powerful tools more efficiently, more quickly, and this allows us to build on top of the foundations laid by hiding away the lower level details. And so now software developers are primarily hired to work in the following key areas. So there was a Stack Overflow survey that was done in which tens of thousands of software engineers and developers responded to the survey, and they responded with what technologies they've worked on, and using this data, Stack Overflow created a correlation chart. And so on this chart, each circle represents a technology, and the size of the circle represents how many software developers actually use that technology. So the bigger the circle, the more software developers actually use that technology. And whenever circles are closer together with a line connected in between them, that represents how correlated those technologies are. So the closer the circles are together with a line in between, the more likely that a software developer using one technology is also going to use that other technology that it's close to. And if they're far away, then there is no correlation to whether someone uses this language and if they'll use this language too. So this gives us a good idea of software development as a whole and the different domains in which software developers are hired into, because most of the respondents in these surveys are professional software developers working in the industry. And so the domains are followed. This is the Microsoft web development tech stack. This is another web development tech stack that's a little older. This is modern web development for the most part. This is mobile development. This is systems low-level programming. This is web development using Ruby on Rails. This is game development. This is electronic development. And then this is mostly cloud computing and DevOps. And then this is machine learning. And this is web development in Python. This is big data. And so that's kind of the domains, how they look. And this is what generally software engineers are hired into these days. Low-level programming is a lot more rare compared to the higher level programming of developing like web apps or mobile apps, because a lot of the lower level details have been mostly taken care of. And so, yeah, this is where most of the talent's hired today. The foundations of software engineering remains the same though. It's using programming languages to instruct computers on what to do. But what we instruct a computer to do can be a lot of things, like all the things shown in this picture. I think it's important to understand what kind of thinking goes into software engineering so you can determine if this is something that you would want to do as a career. And so the most important thing to understand about software development is you have to think logical to be able to create the correct instructions to get the computer to do exactly what you want it to do. Because you need to be very precise in what you instruct the computer to do, because it's only going to do exactly what you tell it to do. So on top of this logical thinking, software engineering is also very much problem solving. You're always problem solving by taking big tasks tasks and breaking it down into smaller tasks. And then you build systems on top of other systems. So kind of like I talked about how machine code, we built assembly language, and then we built a high-level programming languages, and now we have frameworks and other tools. That's an example of software developers building systems on top of other systems to abstract and hide away a lot of the lower level details. And as a software engineer, that's what you're largely going to be doing as well on a day-to-day. You're going to be creating systems that encapsulates complexity and lower level details to expose a simpler interface for other software developers or users to use. So kind of like a car, if you think of a car, a lot of the lower level details and complexities have been abstracted away from you. So there's an engine, there's an axle, there's a lot of complexities behind how the car actually works. But as a user of the car, the only thing you have to worry about is how to use the steering wheel, the pedals, and the gear shift. And so you're going to always be building these kind of digital machines online. And so for example, YouTube, where you're watching this video on, YouTube has created a simple interface for people to use. All they have to do is search a video, then the videos pop up automatically, and then they click the video they want to watch. The YouTube web app is then composed of smaller modular parts. And then within that little modular part, it's broken even into smaller modular parts. And so you can think of the complexity that we hide away. Those are just rules and logic and specific instructions. If this, then do that, else do this. That's the instructions you're giving the computer to do something very specific. Remember the car analogy. And so then once you've encapsulated that complexity with a simple interface, it's kind of like a Lego block where you can plug and play into your software application. So you don't just write code as a software developer, but you also build on top of other tools and frameworks, much like creating a machine with many different parts working together. And so some signs that you might enjoy being a software engineer is if you ever used formulas in Google Sheets or Excel and you enjoy that kind of logical thinking, or if you enjoy building things like with Legos, or you like to systemize, you really like to have a routinized routine and you want to be able to automate things, or maybe you like problem solving and logical thinking, maybe you like crossword puzzles or other kind of puzzles. These are all signs you're probably going to like software engineering. But if you're still not sure, what you can do is you can go to a website called scratch.mit.edu, and this is where you can start creating a game using a programming language called Scratch. It's going to allow you to experience what it's like to think like a programmer. You're going to have to think logically. You're going to have to create instructions using the Scratch programming language, which is basically just drag and drop blocks. And then using that, you're going to be able to create a game. This is going to kind of show you what it feels like to think like a programmer. If you enjoy that type of thinking, it's another good sign that you may enjoy software engineering as a career profession. And so here's an example of a Scratch game I built when I first started learning how to code. It's a little game, you're a little crabby. You can only eat things smaller than you. And as you eat things smaller than you get bigger, and then you can start eating bigger things. But if something touches you when it's bigger than you, it's going to kill you. But if it's smaller than you can eat it and you'll get bigger. So that's the game. And there's logic behind this, right? If we look inside the game that I built, this is all the code that I wrote for it. Notice how there's a lot of logic. If this, then do this, else this. So yeah, this would be a good starting point to see if it's something that maybe you're into. So to actually get hired as a software engineer, you got to specialize in a specific domain though. You can't just learn plain coding and get hired into any role and just like do simple coding. These days, you need to learn the higher level tools, frameworks, and abstractions that we've created to be able to build a specific type of software. So you need to pick a niche and you need to specialize that to get hired. Let's go back to the Stack Overflow survey. Remember that I was breaking down the different domains. And if we more broadly categorize the domains, you can categorize it like this, where this is all application development in green. Application development is basically just a software application that you create that also has a graphical user interface so that users can use it on a computer screen. So for example, YouTube is a web application. The graphical user interface provides stuff like you being able to click play on a video, click a different video. So as we can see, application development is by far the largest domain in software engineering. I think it's something like 65% of software engineers are hired into application development. And within application development, around 75% software engineers are web developers. So web development is just developing applications where the front end runs on web browsers. That's where most people are using software applications. So if you're going to pick a domain, I highly recommend going into web development. That is by far the biggest domain or niche in software engineering. So think about it. Google, Facebook, YouTube, Instagram, these are all web applications that these companies are making a ton of money from. Companies are heavily investing into web development because it's one of the fastest, most effective, and most scalable ways to make money. There's a website called levels.fyi. This is where you can view the salaries of software engineering positions at various companies. And so if you think about some of the biggest companies in the world that have web applications as their main product, we have stuff like Google, Facebook, Twitter, Airbnb, Netflix. Let's look at the starting salaries for these software engineers. And so if we look at Google, 192,000, Facebook, 202, Twitter, 174. This is in the United States, 180 for Airbnb, and 218 for Netflix. And so when I got hired at Microsoft, I started out at around 167. And so I was actually hired at level 60. So I was also working on a web app. I was working on the Microsoft Teams product, which is also used as a desktop application. But these days we also have tools that allow us to build software that can run on a browser and a desktop application using the same code. So the specialization of whether you go for web development or mobile development or desktop development is not as relevant today as it was before. So we have tools that make it so that way the software can run on any platform. So if you want to enter the software engineering field and you don't know where to start, web development is the most in-demand, practical path to go. And it's what most companies are focusing on because it offers the fastest return on investment. What do you actually do on the job when you're working as a software engineer? So as a software engineer, your primary job is to create or to modify software. This mostly comes down to coding using a programming language and also using other high-level tools and frameworks to help you build the software application. And you'll likely use a project management tool like something like Jira, where you'll be assigned a task and where they want you to create a software or modify the software application in some way. And when you get that task, you can start working on that task by downloading a copy of the company's software onto your own local computer. You can then make changes to it, modify it, and then test it on your computer to make sure it looks good. If it's not working on your computer like you expected it to, that's when you start debugging. Debugging is a very common task in software development where you give instructions to the computer to do something specific. It's not doing it how you expected it to do it. So then you have to look at your code, see what's wrong, make some changes, some tweaks to figure out what went wrong. And you do that until you successfully are telling the computer what to do and it's doing it exactly how you intended it to do it. Once you've made the proper changes to the code, you can then upload that code back to where the company was hosting its code, and the company's code will be updated with your new updated code. Although before that happens, there's going to be other software engineers that review your code to make sure it looks good before they merge it with the main code. And you may also write automated tests so that way when you make changes to your code, instead of manually testing it, you can run the automated test to make sure that nothing breaks. And in addition to coding, you're going to want to keep it organized and clean, because if you write code messily, things can get unorganized and it's called spaghetti code, where it's hard to actually read the code and know what it's doing. There's best practices involved in how to structure the code so it's easy to read and understand what it's doing. It's a big part of software engineering. So if you think of like building a car engine, instead of just creating like a bunch of pieces that are all mangled together, you make it pretty, you make it modular, you make the pieces distinct with their own responsibilities and they work together in harmony. It's an art and you should find it satisfying. You may also work with cloud tools, which are basically just tools that allow you to manage what machine your software is running on. So one machine might be hosting the code that's running the code for all users to use the application. That's the production application. So the YouTube video that you're watching this on, you're using the production YouTube application. But there might be a different machine where this YouTube code is running on and it's only for testing purposes, to test new features that software engineers have added to the YouTube code. And once it's tested and it looks good and that code is moved on to the production machine. And so the cloud tools allow you to easily manage which machines are running this code, and you need to make sure the machines are running well together, nothing breaks, and there's a lot of tools and frameworks that make that stuff easier. And then in addition to all this technical stuff, you're also going to communicate with other software engineers on the team. You guys are going to collaborate to try and coordinate your work together to be able to build the application. And then you may also communicate with other stakeholders that tell you what they want the software to do. So you got to understand what they're requesting, and then based off that, you need to then build the software to do what they want. And one of the big perks of software engineering is, besides the meetings, when it comes to like the actual coding, you can pretty much do that whenever you want. Depends on the company, obviously, but normally as long as you're doing the work, it doesn't actually matter when you code. You can also do this remotely. So you can do this on your own time, wherever you want around the world. So it's a great profession if you're looking for flexibility as well. So why do software engineers make so money? I showed you some examples of how much they can make at various tech companies on levels.fyi. And the reason is because software is incredibly scalable. So you think of Google, Facebook, Amazon, Microsoft, they create web applications that millions of people around the world use. So a software engineer can create an application one time, then that application can be used by millions of users. It's going to make the company millions, if not billions, sometimes trillions of dollars. And so that's why software engineers are so valuable, because they have the skills to create products that can infinitely scale around the world and generate massive revenue. And so more and more businesses are investing into software development because that's the key to scaling operations, automating tasks, and staying competitive. And that's why software engineers are in high demand, because companies need people with these skills that can fuel their growth. So if you want to be in the forefront of innovation where the economy is heading, software engineering is definitely where it's at. So I hope this video was helpful in helping you understand what software engineering is and what it looks like as a career today.